Hey y'all, we are here in chapter 1.3 and we have a chapter that is intense, but it's short in writing but long in examples. So I want you to get started with me. Go ahead, write down use distance and midpoint formulas as your title. Of course, as you know, you're going to put whatever date today is that you're taking these notes. And our first word that we're going to start off with is midpoint. The word is midpoint. Go ahead and write that down. And so what a midpoint is if you have a segment, right? Let's say this is the segment I have, and I'm going to call this segment AB. So if I have segment AB and then I find a point directly in the center, in the middle, that's the midpoint. What we know about the midpoint is it's a point that's going to cut the segment directly in half, meaning the length of AM, right, has to be equal to the length of MB. We know that this midpoint is the center of the segment. Let's go ahead and write a definition for that. So as defined, a midpoint is a point that divides a segment, right, into two congruent segments. And that's a midpoint. Let's look at another term that we're talking about here, which is segment bisector. A segment bisector. So if I have a segment, a line segment, let's call this the line segment that we have here. Let's put some endpoints here. Let's call this TU. If I have line segment TU and line segment TU has a midpoint, and let's call the midpoint N, right? Any line or ray or plane or other segment, anything that comes through that point is called a segment bisector. So a segment bisector is going to be a line, a plane, anything that's going to cross through the midpoint of that segment. All right, so that segment bisector could be a point, it could be a line, it could be a plane, it could be a ray, it could be another segment. Anything that is going to intersect the plane, yeah, I'm gonna have to do this again. So a segment bisector is going to be a point, a line, a ray, or even a line segment or a plane that intersects the segment at its midpoint. So that's what a segment bisector is. And in this case, in like our visual example, we just have a line being the segment bisector, but it could be all those other things. So let's take a look at the concept of the midpoint formula. And so midpoint formula is literally a formula, so it's not a definition. I'm going to share with you what it is and the circumstance that you would use it. So the midpoint formula takes us back to the days when we were dealing with the coordinate plane, right? So we have a little X and Y axis business, and I'm going to put 2 points on the coordinate plane. Put my points up here, and I put some numbers on the axes. And so now look at the coordinates of A and B, right? We've got -2, 3 and +4, 3. Can you tell me what the midpoint of that segment would be that would connect that? What's the midpoint? So here, let me draw this segment real quick. Where would the midpoint be? Pause, look, see what it is. I'm thinking you guys are pretty slick and you would be able to see that the midpoint, let me use a different color pen here, that the midpoint would be right about here. That's about the midway. And if that's what you suggested, then you were correct. C is the midpoint, and that is going to be at +1, +3, right? Not too bad. Well, let's change the dynamics real quick. So what if we move B down here, say to 0.41? Now can you tell me what the midpoint is? Pause, see if you can find it. If you paused me and you tried, I'm hoping you got somewhere around here. What we're going to do to find this midpoint, let me call it M because that's better letter for a midpoint. What we're going to do is figure out how we can do it without eyeballing it, drawing lines, and figuring out where it is. This point, by the way, is at 1, 2. Can you see any relationship between the coordinates of A, the coordinates of B, and the coordinates of the midpoint M? That's what the midpoint formula is about. So here's what I want you to do. Write this formula down, please. The midpoint is equal to, I know this is going to seem crazy, x sub 1 plus x sub 2 divided by 2, and then y sub 1 plus y sub 2 divided by 2. So this will be the new x term for the midpoint, and this will be the new y term for the midpoint. Let's take a look at the colors. So I'm telling you that if I took the x value of the a term, that's why I made it red, that would be x sub 1 because I'm calling this like the first point. So if I took that x value and put negative 2 here, and then took the x value of the b term and put a plus 4 here, and then added those guys up and then divided by 2, that would be my new x term for my midpoint. Let's see if that's true. Negative 2 plus 4 is positive 2. Positive 2 divided by 2 is 1. Let's try it again because we need to do that same thing again for the y term. Let's take our y term of the a point, and that's going to be 3. I'm going to add to that y sub 2, which is the y term of the b point, which is 1, and then I'm going to divide it by 2. 3 plus 1 is 4. 4 divided by 2 is 2. So without actually drawing the picture, we can actually get the midpoint, right? This formula is going to be really helpful. Make sure you write it down. If you find that it is difficult to understand, please let me know in class. I want to talk to you about it. That was a difficult formula, but we have an even more challenging one. This one's called the distance formula. Okay, so the distance formula is a little bit different than the midpoint formula in that the midpoint formula finds the middle point that would be associated with this segment, but here we want to find the length of it. And hopefully if you've been in class, you know that what we're going to do is we are going to kind of utilize the Pythagorean theorem. We're going to create a triangle. That is a right triangle because we can only use right triangles when talking about the Pythagorean theorem, or the Pythagorean theorem only works with right triangles. And we're going to exploit this relationship. If I can find this length and this length, then I know that I can find the length of AB because our formula says one side is going to be A, and that side is going to be either the horizontal or vertical one. The other side is going to be B. We call these, by the way, the two sides that create that right angle, we call them legs. So A, B, and then the hypotenuse, or this longest side, is C. So we know in the Pythagorean theorem, the way these sides relate is as follows. A squared plus B squared will equal C squared. Now that we have this idea together, if I wanted to solve for C, or AB, I would have to take the square root of both sides. When I do that, I get that C is equal to the square root of A squared plus B squared. This all comes out of the Pythagorean theorem. So what does that have to do with the distance formula? Well, I'll show you. How do we find the length of A? We'd have to figure out how far over it is, how far this point is from this point. And so we'd count 1, 2, 3, 4, 5. Let me make that a little bit neater so you can see that I'm not just doing crazy stuff. So we'd make this 1, 2, 3, 4, 5. So in this case, A would equal 5. And so 5 squared is what I'd be doing there. And then I'd have to figure out what B is. B would equal 1, 2, 3. So the length of B is 3. So I put 3 squared here. And when I take the square root of that, I'm going to get what the length of C is. With a little bit of quick math, we get that that's 25 plus 9, which is equal to C. But I'm going to have to take the square root of that, right? So the square root of 25 plus 9 is going to give me C. That's 34. Square root of 34 is equal to C. How can we do this without drawing the picture? That's what the distance formula gives us. So without having to draw this, this is what we do. We recognize that A, right here, is going to be the difference between these x values. Watch this. Remember when we found the distance, we found the subtraction, the distance, the absolute value distance between two numbers? We're going to do that here. 2 minus a minus 3 is 5. So we would get that this length is 5. So what we're going to have here for A is as follows. A would be the difference between these two numbers. Generically speaking, if I call point A x sub 1, y sub 1, and point B x sub 2, y sub 2, then the points that would give us the value of A would be the difference between x sub 2 and x sub 1. So the first thing is I'm going to replace A with x sub 2 minus x sub 1 quantity squared. The next thing I'm going to do is calculate B. As we can see that B is going to be 1 all the way up to 4 here. So 1, 2, 3, that's going to be a space of 3. Or we could think 4 minus 1 is 3, right? The difference between the y terms. So we're going to calculate the difference between the y terms and get y sub 2 minus y sub 1. Remember, y sub 2 is up there. Y sub 1 is the value, I'm pointing with my finger, you can't tell, the value down here for this point. So y sub 2 minus y sub 1 quantity squared. We're replacing B with y sub 2 minus y sub 1 and we get quantity squared. And if we just plug these values in, we would get C. So that means I can give you 2 points and you can use the distance formula and find the distance between it. So between those 2 points. So here's what the distance formula looks like. It says D, the distance here, it could be AB, it could be C, but really we're going to use the letter D when we're talking about distance, is equal to the square root of the following: x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. And if you feel like you've seen that before, go way back in the day when we first gave you the packet and you will see that it's right here. So not only is the midpoint formula here, also the distance formula is there as well. All right, babies, please go ahead and turn to example 1 in section 1.3. That's what we're working on. And so let's talk about it. Let's do these examples. In skateboard design, VW, that's this segment here, it bisects the segment XW. So what that tells us automatically is that we use these little hatch marks to say this segment and this segment, they're definitely equal in length. So it bisects it there. If XT is 39.9, find XY. So if XT is 39.9, we know that, let me write it down, XT, no line at the top means the length, is 39.9. Something else here has to be 39.9. And if you said TY, you are on it. So TY must also be 39.9. If those two are 39.9, by segment addition postulate, you didn't know all this stuff went together, did you? But it does. XT plus TY is equal to XY, and that's what we're looking for. So that 9 plus 39.9 plus 39.9 is going to give us 79.8, which is the length of XY. Let's move on to example 2. Here in example 2, we're given that M is the midpoint of this segment VW. Find the length of VM. This seems really hard because there's no numbers given. But remember, if you can come up with an equation, if you can set two things equal to each other, oftentimes there's a lot of cool things that you can do, and we can in this case. So segment VM has to be equal to segment MW in terms of length. Since that's the case, that means that 4x minus 1 has to equal 3x plus 3. And this is an equation that I can solve. You know how I like to solve my equations. I like to draw a line right down the middle. I like to tell you what I'm doing. I'm going to end up with my x terms over here, and I want my constants over here. And I'm just going to solve. I know if you're faster than me, you can zip through this part, but I'm going to take my time. If I want x terms here, that means 1 has to go because that is a constant. I'm going to add 1 to both sides because that's a minus 1 that I'm getting rid of. I get 4x on the left side, and on the right side, I get 3x plus 4. Now I want constants to stay here, but this x term has to go. To get rid of that 3x, I'm going to add its opposite, which is negative 3x. When I'm done, on the right side I have 4, and on the left side I have x. So x is equal to 4. I'm not done though. They didn't ask me what x is, they asked me what is the length of VM. That's this whole side here. So I'm going to take that 4 and plug it in. So VM that segment length is going to be 4 times the length of x, which is 4 minus 1. VM is therefore equal to 15. For this one, we're asked to use the midpoint formula. I'm going to draw a picture too. You don't have to draw the picture every time, but you might want to draw it now just so we can make sure it visually makes sense. It says find the midpoint. The endpoints of RS are at 1, -3 and 4, 2. Find the coordinates of the midpoint. Let's do that. I'm going to draw an XY axis. So I've highlighted points RS, and I'm going to draw the segment here. Let me use a pen instead of a highlighter. I'm going to draw the segment RS. What we're asked to do is to calculate the midpoint. We don't need to draw this picture. I'm telling you that. I just like to do it because I think it's going to help us visually see how things are working out. We're really going to use the midpoint formula. The midpoint formula, as you know, and you should have it on the front cover, you should have it in your notebook, would be this. Take the x coordinates of our points, and so in this case we're going to get 1 plus 4. We're going to divide that by 2, and then the y coordinates, which is 2 and -3, 2 plus a -3, and then we're going to divide that by 2. And this is going to give us our midpoint. 1 plus 4 is 5. 5 over 2 is 2.5. Or I'm going to write it as 5/2 because fractions don't hurt anybody. And then over here, we're going to get 2 plus -3, which is a -1. Divide that by 2, we get -1/2. This is the midpoint. Let's see if that bears out. So if I go to 2.5, so here's 2 and here's a half, and then I go down a half, I'm right here at the midpoint. Does that make sense? That's exactly what we were told. We didn't have to draw the picture, but it did help to have it. Let's do this next one. We're going to do JK, and we're going to figure out what the endpoint is. So look, we're going to be given the midpoint, and then we're going to look for the endpoint. Let's draw this picture. So this time our circumstance is a little bit different. We're given that the midpoint M is here. We're given that this is one endpoint and we're looking for the other. Clearly the endpoint would have to be here from drawing it, but how can I calculate this without drawing it just by using the midpoint formula? First, let's rewrite the midpoint formula. And let's acknowledge the fact that the midpoint we already know has coordinates 2, 1. So our midpoint would be 2, 1. The next thing we need to do is write down the information that we know we would need. So we know x plus 1 plus x plus 2 divided by 2 is going to give me 2. And then we know, now that's for the x term, and then for the y term, we're going to get y sub 1 plus y sub 2 divided by 2 is going to give me 1. Let's put in the information we already know. We know that J is 0.14. So let's go ahead and put that into the mix. So if I'm going to place that in here, I'm going to say that x sub 1 is 1. And y sub 1 would have to be 4. So the question is, what's x sub 2 and y sub 2? That's going to give us the next point. Well, the question is how to solve this. 1 plus some number divided by 2 is 2. You might be able to guess and check it, and that would be pretty simple. You could look for a number that you put in here. When you divide it by 2, you get 2. That number is going to be 3. But let's say that's a little challenging. Here's what you can do. Multiply both sides by 2. Because what you do to one side, you got to do to the other. And you get 1 plus x sub 2 is equal to 4. Now you solve that. Subtract 1 on both sides, and you'll see that x sub 2 is equal to 3. So I know that the x term of our new point, or our endpoint, is going to be 3. Let's find that y term. Again, 4 plus y sub 2 over 2 is equal to 1. Let's solve it how we solved the last one. Multiplying both sides by 2 to get rid of the 2 in the denominator, I end up with 4 plus y sub 2 is equal to 2. Subtract 4 on both sides. When I do that, y sub 2 is equal to -2. So I've got 2 and I've got 3 rather, and -2 as my coordinates of this endpoint. So I go over to 3, go to -2, and here's this endpoint. Let's call the endpoint K. Endpoint K is at 3 and -2. And you can see that indeed, that looks about right. Let's go ahead and look at this next example. Standardized test practice. This is our final one. What is the approximate length of RS with endpoints 2, 3, and 4, -1? If we're asking about length, we're talking about the distance formula. The distance formula is going to be at play here. Instead of drawing pictures this time, I promise we're just going to use the formula. So the distance formula tells me that D is equal to the square root of the difference between the x terms, x sub 2 minus x sub 1, quantity squared, plus y sub 2 minus y sub 1, quantity squared, and I'm going to take the square root of it. Let's go ahead. So if I have 2 points, 2, 3, that's R, and I have S, which is 4, -1, let's go ahead and assign them values so that it can make a little bit of sense. So I'm going to call R my x sub 1, y sub 1, and I'm going to call S my x sub 2, y sub 2. To be honest, this can be done interchangeably. It's okay. But I'm just going to call it as it is now. So the distance will equal the following. The distance between, it keeps doing it, the distance between x sub 2 and x sub 1, or the difference, is going to be 4 minus 2. So watch me just replace everything. 4 minus 2, quantity squared, plus -1 minus 3, quantity squared, square root is going to give me D. So that means, let's simplify in the parentheses. 4 minus 2 is 2, so I get 2 squared plus -1 minus 3 is a -4, so that becomes -4 squared. When I add those together and take the square root, I've got the distance. I'm almost there, guys. 2 squared is 4, plus -4 times -4 is 16. I end up with the square root of 20. Now, for those of you who are good at this, we can actually simplify. The distance is equal to the square root of 20, which is actually simplified to the square root of 2, the square root of 4, which is 2, times the square root of 5. So we can write 2 root 5, or if we were to use our calculators and get an approximation, I know that that answer is going to be somewhere between 4 and 5. And when I check my calculator, I get the approximate value of 4.47. So that is the final answer that I have. Now they asked us, what is the approximate length? So if we're taking a standardized test and the answer choice is there, which one's the best answer choice? My hope is that you guys would choose C, 4.5. All right, guys, that's a lot of notes. I want you to make sure it's making sense. Don't just copy stuff. Anybody can copy stuff, but understanding is the key. Let me know if you understand it. I look forward to talking to you all soon. Take it easy. Bye-bye.